Hi, in this video we're going to look for the introduction of what's known as the remainder theorem and look at polynomial division. The whole aim of this is so that we can solve polynomial equations bigger than degree 2. So when solving a quadratic, which is a polynomial degree 2, ax squared plus bx plus c, we can use the methods of factorization, not always possible, and when it's not possible we can use completing the square or use the quadratic formula, which is a form of completing the square. And we all know that the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, however, there is no simple formula for polynomials of higher powers like cubics or quartics. So, however, we can use both the remainder theorem, which is what this video is going to introduce, and the factor theorem to help us find the roots of polynomials. What we mean by roots is actually being able to solve polynomial equal to 0. So, the remainder theorem. Let's take a very simple look at polynomial division with a very simple quadratic, x squared minus 7x plus 10. We know that factorizes into x minus 5 and x minus 2. And we can check that by expanding if we're not sure. We can pause the video to do that. Right, if we call the original polynomial, this is polynomial degree 2, f of x, and we'll call x minus 5 factor x minus a. Then x squared minus 7x plus 10 we know it to be equal to x minus 5 times x minus 2. Or we could write this as x squared minus 7x plus 10 over x minus 5. And if we do the division, okay, now to do polynomial division, you must set things out very, very carefully. So we've got x squared minus 7x plus 10, and we've got x minus 5 into x. So what you do is you take the x and divide it into x squared, and that goes in x times x makes x squared. By long division now, so multiplying out x times minus 5x is minus 5x. And then what we do is we do the subtraction, minus 7x minus 5x gives minus 2x. And then normally you bring down the next number, so we'll bring down the 10, so we've got minus 2x plus 10. And now we do minus 2x divided by x, which gives me minus 2. Minus 2 times x gives me minus 2x, minus 2 times minus 5 gives me plus 10, and if we now do the subtraction we get no remainder. So we say, if we call this g of x, okay, and then we've got that x squared minus 7x plus 10 over x minus 5 is equal to x minus 2. So what we've got here is, if we note, f of x, which is the original polynomial, divided by some factor x minus a is equal to g of x, the answer. So the divisor is x minus a. Or we could write that as f of x is equal to x minus a times g of x. There's further examples of polynomial division. You could pause the video and try them for yourself. So we've got x squared plus 10x plus 24 divided by x plus 6. X squared divided by x gives me x. X times x gives me x squared. X times 6 gives me 6. X squared minus x squared gives me nothing. 10x minus 6 gives me 4x. We bring down the 24. And then we do 4x divided by x, which gives me 4. 4 times x gives me 4x, and 4 times 6 gives me 24, and again if we do the final subtraction we get no remainder. So again, that we'll call that f of x. This is the divisor x minus a, or the quotient, and this is the answer g of x. So again, writing it out as a division, we've got x squared plus 10x plus 24 over x plus 6 is equal to x plus 4. So we've got f of x, x minus a, and g of x. If we've got x squared minus 5x plus 6 divided by x minus 3, Again, x squared divided by x gives x times x gives x squared, x times minus 3 gives minus 3x, x squared minus x squared gives you nothing, minus 5 minus minus 3, minus 5 plus becomes minus 5 plus 3, so it gives minus 2x. So you have to be careful with your negative numbers. Bring down the 6, minus 2x divided by the x there gives me minus 2, and we get minus 2x plus 6, no remainder. Again, f of x minus a, and this is g of x. So we're going to end up with f of x over x minus a is equal to g of x. So note, f of x over x minus a is equal to g of x, and therefore f of x is x minus a times g of x. Now, if we put f of a in, then we're going to get a minus a times g of x, which is going to be equal to 0. And that's going to give me the value of what a is, provided I substitute the right value in for me to do this. So there's no remainder, and this is the idea of the remainder theorem. However, let's see how it works for a polynomial division for a cubic. So we've got 8x cubed minus 4x squared plus 6x plus 7. So we do exactly the same. You must make sure you lay things out correctly, and if there's no x squared term, you must leave like a space, or if there's no 6x term, you must leave a space. And you must put everything into the right column. So you've got 8x cubed divided by x, which gives me 8x squared. You must put that above that column there. 8x squared times x gives me 8x cubed. 8x squared times minus 1 gives me minus 8x. Nothing from here when you do subtraction, but minus 4 minus minus 8 gives me plus 4x squared. Bring down the next one, which is 6x. So you now do 4x squared divided by x, which is 4x. That will go here. And then you do 4x times x, which gives me 4x squared, and 4x times minus 1, which gives me minus 4x. Do the subtraction, nothing from here. 6 minus minus 4 is going to give me 10x. Bring down the 7. Okay, and then 10x divided by x gives me 10. 10 times x gives me 10x, and 10 times minus 1 gives me minus 10. So 10x minus 10x gives me nothing, but 7 minus minus 10 is going to give me 17. So this time we've actually got a remainder. So again, we have to call this f of x. This is called x minus a, and g of x. One thing to note, if x minus 1 gives a remainder, then this is not a factor of this. So we call the remainder r. So rewriting it the other way, 8x cubed minus 4x plus 6x plus 7 over x minus 1, so f of x over x minus a is going to be 8x squared plus 4x plus 10 plus 17 over x minus 1. If you think, when you divide 7 by 4, 4 goes into 1 time, remainder 3 sevenths. So it's the same idea here. 17 over the divisor. The remainder is always expressed over the divisor. Right, just writing that out again. Now, what we can do, in order to have the same denominator everywhere, okay, is we can multiply the top and bottom of this by x minus 1. So multiply the top by x minus 1 and the bottom by x minus 1, we haven't changed the meaning. And now, because we have the same denominator, we can just ignore it. We can say that 8x cubed minus 4x plus 6x plus 7 is going to be x minus 1 times 8x squared plus 4x plus 10 plus 17. So what we're saying is f of x is equal to the divisor multiplied by the answer plus the remainder. F of 1 in this case would give 1 minus 1 times g of x plus 17. And 1 minus 1 is 0, so 0 times g of x. So f of 1 would actually give me the remainder, and this is what the remainder theorem does. 0 times 0x plus 17. Therefore, f of 1 is equal to 17. The remainder r. So therefore, f of a will give me the remainder, and this is known as the remainder theorem. So if I want to divide this by x plus 2, for example, if I substitute in minus 2 into here, okay, it will give me the remainder. All right, and what I'm saying in this case, if I divide it by 1, if it's the opposite to here, so it's minus 1, so this is plus 1. If I put 1 in here, 8 times 1 cubed minus 4 times 1 plus 6 times 1 plus 7, the answer is 17. So this gives me the remainder, and this is why it's known as the remainder theorem. And the idea is, in the next video we'll explore this, if we put a number in here such that we will get a 0 for the remainder, then we know that this this divisor here would be a factor in this case. Okay, so this is a video to explain the remainder theorem. I hope you've understood, and I thank you very much for watching.